All right, now here's a desert ghost, Mario. Mario Gene reduces pattern. It lightens things up a little bit. Combined with desert ghost, which already does that as well, you get a really, really nice looking desert ghost. Dave Palumbo here for Muscle Serpents Daily, and today we're going to be talking about genetics. That's right, we're going to be talking about the desert ghost gene in ball pythons. And what makes that so special? Well, it is a beautiful gene. It does lighten things up. It keeps the blacks black. It dilutes the other colors. It has, and some people say it actually has a little bit of a pattern anomaly as well as part of its charm, so to speak. But what I'm more interested in is the genetic inheritance, because we always thought of desert ghost as a simple recessive trait, meaning that if you have 2 copies of it, you visually see it. If you have 1 copy of it, you have a het, which is a carrier. And if you have no copies, you don't see it. So the only time you see desert ghost would be if you have 2 copies of the gene. We've found out through some genetic testing in a project, I guess, that's being spearheaded by a man by the name of Benson. He is testing all the genes so that you could basically send your sheds in. The peacocks are, they want to be tested, I guess. You can send your sheds into Benson, and he will tell you if you have het pieds, he'll tell you if you have het clowns, he'll tell you if you have het albinos, just by testing the genes. And he's elucidated a number of genes. The latest one is the desert ghost, and what he found was that there is not 1 desert ghost gene. There's actually 2, and even possibly a 3rd. Now they're finding that they think there's very possibly a 3rd, and they're calling them desert ghost A, desert ghost B, and desert ghost C. Now there could potentially be some other smaller genes too that are involved in the color of the desert ghost project, but it seems like these 2 main A and B genes are the main ones that will give you the desert ghost look. Now, if you have 2 copies of A and 2 copies of B, you're going to have the best looking desert ghost you could possibly get. If you have a variation of the other 2, maybe not so much. And that's why some desert ghosts seem to have a higher expression than others. Now I'm going to explain it. I'm going to show you some desert ghosts that I have, a couple of them, and I'm going to go through exactly what Benson has discovered, and I'm sure in the future we're going to find out a lot more. So stay tuned. Let's go into the snake room. Look, I walked outside. The peacocks are coming running, especially my pied and what I believe to be a leucistic, or maybe a pied, little baby. They came running because my kids feed them bread all the time. So they think my house is like a buffet. I got the male there. I got the 2. I think this guy's going to turn into a male. He's still a baby. And that's the mama right there. You're so good. Come here. She's like, where's my hamburger rolls that I always get from you guys? Well, guys, I'm walking down here because I wanted to show the Muscle Serpents University watchers and viewers a little lesson I want to give them. We got the egrets over there. Let's see. They're eating their worms. It just rained. Peacocks are also picking up earthworms here. And I wanted to show you something interesting. I showed you some of my my fruit trees the other day. Now, I actually planted a bunch of these cacti plants. Cactuses are my favorite, and I've been rooting them in water and planting them all over my yard because I love them. They're growing. I don't remember the name of this tree, but they drop these little orange seeds here. See that? And those orange seeds sprout these little baby sprouts, and they'll grow into trees just like this thing. My wife doesn't like them. She thinks they're like weeds, and they theoretically potentially could be weed-like because they do reproduce so much and so quickly. But I thought there was one over here that took root. This plant was not something that I planted. Matter of fact, if you see how the roots are above ground, you'll see, this is my son's Captain America shield, you'll see that this was not planted very deeply in the ground, but the roots did go deep into the ground. Now, I figured it was one of these little pods that grew into what these things start with. But then I looked up and I came and inspected it, and I realized it's a papaya tree. Now, I don't have papaya trees on my property. I didn't plant the papaya tree, but yet a papaya tree is here. And you can see by the way the roots are superficially growing on top of the ground that this obviously was a seed that blew here and somehow it sprouted. I didn't pull it out of the ground because I didn't realize it. And I like to give things a chance to grow. And now I have a papaya tree growing in my yard. I had one years ago that got blown over by a storm. We had when we first moved here about 7 years ago. But some of the neighbors have papaya trees. I have a feeling from the last hurricane we had that some seed somehow mysteriously got blown over here. It took root, and I have a papaya tree. So now you wonder how some of these island boas sometimes wind up on islands. A lot of people think they float potentially on logs. Some of them swim. Some of them were there before that, and the landmass was cut off by the rising oceans. But life finds a way, as Jeff Goldblum said in Jurassic Park. And this somehow, a papaya seed planted itself in my yard, and I have a papaya tree now. So I love it. All right, guys, I want to talk to you a little bit about the desert ghost gene. There's a lot of controversy now in the industry. People are getting all upset. You know, there's a project that's being undertaken, a tremendous project where they're trying to map some of these genes so that we can tell by sending in sheds whether we have a gene or not. Like if you think you might possibly have a het clown or a het pied, you can send a shed in, they can do some DNA sequencing, and they can tell you, yeah, you have one copy of clown, you know, or you have one copy of pied, even though it might have been a possible het. And that's great. And a lot of the genes that they've been elucidating, and I guess we're working on the Desert Gene project, speaking of which we have a nice pastel desert ghost female right here. And they got some results that kind of surprised them. Now, we always think of desert ghost as a recessive trait, meaning if you have one copy, you have a het. If you have two copies, you have a visual animal. And it's that easy, right? It's like clown or pied. Well, turns out with desert ghost, it's not quite that easy. They've actually found that this gene is a polygenic trait. Now, polygenic means many. So there are several genes that contribute to the way a desert ghost looks. What are those genes? Well, the good news is that it's not a lot of genes. Like, if you look at like height in human beings, there could be like 1,000 genes that contribute to height. So if this polygenic trait was like 10 or 12 genes, we would never be able to figure it out. But it's not. It seems like it's 2 or 3, maybe a couple more, but 2 main genes that really will dictate how this snake looks color-wise. And I think desert ghost does affect pattern a little bit too, in my experience. The 2 genes they're calling desert ghost A and desert ghost B. Okay, it's not that hard. A lot of people are freaking out. They don't understand it. It's too complicated. It's really not complicated if you think about it. Desert ghost A, if you have 2 copies of it, you're going to have a desert ghost looking snake. Desert ghost B, if you have 2 copies of it, you're going to have a desert ghost looking snake. If you have both genes, desert ghost A and B, and you have 2 copies of it, guess what? You're going to have a even more intense looking desert ghost snake. So there's multiple ways. Now, also, if you have 1 copy of desert ghost A and 1 copy of desert ghost B, you can also have a desert ghost. So there's 4 ways you can get a desert ghost. 1 copy of A and B, 2 copies of A, 1 copy of B, 2 copies of B, 1 copy of A, and then 2 copies of both. Obviously, the one where you have 2 copies of both A and B, you're going to have the highest expression desert ghost, and supposedly those will look the best. Now, the problem is that no one knows what they have. Now, if you send in your sheds to Benson, Benson's the guy who's been doing all this research, he can tell you how many copies of A and B you have. Now, here comes this is the kicker. This is the thing that's been really, really confusing people. They think there's a desert ghost C gene that does contribute also. Not as heavily and not as strongly as A and B, but they think that there's a C because there's still some anomalies where people are breeding desert ghosts and they're not getting a visual. Okay, it doesn't happen very often, but it does happen. I know Justin Kabilka said he sees it sometimes in his collection. Now, is it a very low expression are they getting, or are they not getting a visual? It's possible. It's possible that, like, if you had one copy of Desert Ghost A and you have one copy of Desert Ghost C, you'd get a visual. But if you only had one copy of A, you wouldn't get it. So I don't know. No one really knows what's happening because no one is sequencing the ones that are not showing up as Desert Ghost. You know, if you breed Desert Ghost to Desert Ghost, you should get Desert Ghost, right? And then most of the opportunities and most of the times you do that, you do get it. But every once in a while there is an anomaly. So that's why they think there's a third gene. So how does that affect us as ball python breeders? Well, it really doesn't. Because if you're breeding Desert Ghost and you're getting Desert Ghost, okay, even if the expression's a little different, you're still getting the outcome that you want. Now, if you're an absolute neurotic and you only want to work with Desert Ghosts that are both homozygous for A and B gene, then the only way to know that would be to actually get genetic testing done. And then it's going to take a lot of work to try to get animals that are homozygous, which means 2 copies for A and B. I don't think it's something that most people have to worry about. I think for most people, you breed Desert Ghost to Desert Ghost, you're going to get Desert Ghost. If you breed a Desert Ghost to a het Desert Ghost, most of the time you're going to get 50% of the babies are going to be Desert Ghost. What a lot of people are seeing is they're getting more than 50% of the time they're getting Desert Ghost babies because of the fact that there's 2 genes involved. So, not to confuse people, but this gene is just something that I think we're going to find there are other genes in ball pythons like that. Some people are speculating that Mandarin might be like that. It might be more than one gene because we do see different levels of expression. I've seen single copy Mandarins that are super red. I've seen single copy Mandarins that are, you can barely tell a Mandarin. They just have just a little sprinkle of reds in it. And that could be because there's multiple genes contributing. And so hopefully they'll be mapping that gene out next. And it's you know what, the more knowledge we have, the better decisions we can make. And to me, I'm a genetics freak, so I like all this stuff. To me, it makes it more interesting. It's not less interesting, but I know for some people it becomes a little overwhelming and they get freaked out. Don't get freaked out. Continue your projects. Most of the time, this is not going to affect anyone's outcome. You breed het to het, you're going to have a 25% chance of getting a Desert Ghost. You breed visual to visual, most of the time you're going to get all visuals. And if you breed visual to het, 50% of the time you're going to get visuals. So it's nothing to be freaked out about, but it is kind of cool to geek out sometimes on the genetics of what's going on. Now, this is a Russo Red Pastel Hypo Sterling, which is a patternless boa. The Russo Red Pastel is a line-bred trait, meaning that it's in boas, line-bred traits are what we call polygenic traits, meaning multiple genes contributing to a look. You see that red eye, you see this red body here. Those reds are from line breeding, meaning picking the reddest of red snakes and breeding them generation after generation. That is not due to a single gene, that's due to multiple genes that contribute to this look. Who knows how many? It could be 10, 15, 20 genes. But if you breed the reddest boas to the reddest boas, generation after generation, you're going to get redder and redder genes, because redder and redder snakes, because you're picking more and more genes that code for red. That's what polygenic means. So now when we go back to the ball pythons and we start to see, hey, there are some genetic morphs in ball pythons that are considered polygenic. Now you know what I'm talking about. Many genes, several genes contributing to a certain look. And with regard to Desert Ghost, which we're going to see in a minute, it's going to be 2 main genes and then possibly another third gene that contributes to that, with possibly several other mini genes that contribute. So not quite as complicated as something like this Russo Red, which probably is, like I said, a lot of genes involved in this. But it is kind of interesting to see that now in ball pythons we're seeing that there are polygenic traits, not just all single dominant, incomplete dominant, and recessives. Here's another line-bred trait in boas. This is the Flamingo Pastel, which gives a lot of reds, and the Red Tiger. So this is 2 line-bred or 2 polygenic traits in this one snake that give it this really clean, reddish, saturated look. And there's only one actual incomplete dominant in this, and that's a hypo gene here. But that's it. There's no other genes that are making this look like this. It's just line bred, multiple genes contributing to a single look. And we see this a lot in boas. There's a lot of cool polygenic pastel lines, as we call it. Whereas in ball pythons, the pastel is actually an incomplete dominant. But when we say pastel in boas, we're talking about polygenic line bred traits. Multiple genes contributing to a certain look. All right, now here's a desert ghost, Mario. Mario gene reduces pattern. It lightens things up a little bit. Combined with desert ghost, which already does that as well, you get a really, really nice looking desert ghost. I really love this combination. Actually, we've been doing a lot of breeding with this boy. I really want to see what we can do because I think that it really contributes. Matter of fact, this is such a nice looking desert ghost, and a lot of people say, wow, it's the nicest looking desert ghost I've ever seen, or one of the nicest. And the reason is I think that Mario gene has a contributory action to desert ghost. So just like we say desert ghost is polygenic, meaning multi-genes, two predominant genes, the desert ghost A and B, with a C that we haven't figured out yet, which they're working on. But imagine if like something like Mario has a similar effect to desert ghost. So now it's like a third gene you're throwing in there that actually does the same thing or very similar to desert ghost. So of course you're going to get a better looking desert ghost. The reason I show you this is not to confuse the matter, because this is a different gene. This is a Mario gene. But the point is that the more copies of these polygenic desert ghost genes that you get, whether you get A, B, and C, you're going to have a much nicer looking animal. Okay, so you still have desert ghost there if you only have one of the copies, if you only have like desert ghost A or desert ghost B, but if the more you get into an animal, the better the animal is going to look like. Now, some people don't care. Some people just want to say, I got desert ghost in there, I got clown in there, I got Enchi in there, I got leopard, and that's all there is to it, and I'm going to sell it for this much money. But some people do care about, I really care about how a snake looks. If I can make the snake look better because I have more of the desert ghost genes in there, I have A, B, and C in there, and I can confirm that with genetic testing, I have to believe that the animal is going to be worth more money. Because when you breed that animal to other animals, you're going to have a much higher percentage of desert ghosts you're going to get, and better looking desert ghosts, because you have all those copies of all those genes. And it's amazing that we can even test for all these mini genes, these other genes that contribute, because think about it. Just a year ago, we couldn't do that. We didn't know what we got. We just looked, if something looked good, we were like, we'll keep this one. It looks nice. No one knew that there was a difference. Now we can actually tell, and we can actually genetically test, and we can mark that down on our breeding card for our snake and say, hey, this snake not only is desert ghost, but it's got 2 copies of A, and it's got 2 copies of desert ghost B, and maybe in another 6 months we'll find out where the C gene is, and we might say, oh, it's got 2 copies of the C gene. And that's why this desert ghost is the best looking desert ghost anyone's ever seen. So once again, and then we can find other genes that contribute, just like this Mario gene does. And we can say, hey, if we add Mario, and we add this, and we add Mandarin, we're going to see even higher expression desert ghosts. And to me, that's super, super exciting. All right, now I want to show you my Mandarin genes. This is a Mandarin that we produced in 20. I always speculated whether this was super Mandarin or single copy Mandarin. She's probably one of the highest expression Mandarins I've ever produced. I'm breeding her this year. Hopefully we'll get some babies. If we get, everything comes out Mandarin, then we know she's super, but she's really high expression. And then here's another male I produced a year and a half ago, and he's Mandarin too. And look at the difference. This is definitely Mandarin. I can see the pattern and I can see the Mandarin in there, but you could see a tremendous difference. Now, if this is super, obviously that would make a sense, but I have a feeling this is single copy Mandarin. It's just high expression. Now, why is this high expression so red compared to this one, even though, theoretically they're both 1 copy of Mandarin? Now, the way to explain this would be if Mandarin is polygenic, which we don't know. Maybe this snake has 3 genes that have Mandarin in it, and this one only has 2. And that's why this one, even though it's single copy, has a better look than, say, this one does. But they both will pass it on similarly, but you know, this one would pass on 2 copies on different genes. This one might only pass on 1 copy, or maybe this one has 2 copies, this one has 3 copies. We don't know. And once they map the Mandarin gene, we'll be able to find out. But Mandarin is one of the most exciting new genes. You know, I sell a lot of Mandarin stuff here. We have a lot of different Mandarin combinations we're making. And I just know, all I notice is that it's the expression level of a single copy of a single, in other words, where I breed, you know, something, I get a copy of Mandarin, it's always different. Some of them have more color, some don't have as much color. And I don't know if that's just the variability of the gene or if there is multiple genes that contribute, and we're gonna find that out. So that's future tech, but thought it was worth pointing out. Ah, look at that lock. That's a great lock. That's a pied het clown female who is locked with an Enchi clown het pied male, which is great because any baby reproduced that's not visual is going to be 100% het, because female is pied and the male is clown. And hopefully we can produce some more Enchi pied clowns. That's, can't have too many of those. Great little lock there. What a late season we're having. I can't believe it, but I've never had such a late season where I'm getting locks in almost July. We're gonna have 1 million eggs in the fall. It's crazy. All right, guys, that's gonna do it for today here at Palumbo's Pythons and Boas. A little genetics lecture, but I love this stuff. I'm a genetics geek. I can't help it. I love to find this stuff out, and thank you, Benson, for putting all the time and effort you have into these projects of trying to elucidate all these genes and be able to identify them. I think it's really gonna raise the hobby up to another level, especially for ball pythons. I only could hope that you would do that for boas and some of the other carpet pythons and some of the other snakes out there that we're breeding as well, because it's always nice to know what you got just by sending in a shed. The desert ghost gene is certainly different, and it is certainly not going to be the only gene that we find that is polygenic in ball python breeding. I predict we'll see many more. Orange Dream might be one of them. Mandarin may be one of them. And I'm even thinking T positive might be one of them as well. We have different lines of T positive that are not compatible with each other. Perhaps they're polygenic, because if you have 2 like if you have a caramel and you have an ultramel, you produce, you know, a caramello, and they look even better than the original caramel. So I think that there's a lot of excitement coming for ball python breeding. Just when you thought it was getting boring, I think it's getting more exciting. And Benson is really doing an amazing thing for our hobby. We should support him wholeheartedly and give him all the help that he needs to help bring more light onto how we're producing these incredible morphs in ball pythons. All right, on that note, guys, make sure you hit the subscribe button, turn on those notifications, hit that like button, and I'll be back again tomorrow morning.